This video is going to go through the applications of the number E. So the last class, the last lesson was talking about this E. It's called Euler's number and how we used it with exponent rules, how we graphed it, how we found it on the calculator. So today's going to be the application piece, which is interesting because it actually has a lot of money-based questions that I think will make a lot of sense to you. So, if you think back to what we've done so far when it comes to applications of growth, to this point, we've done what I would consider basic growth or basic decay. So, I actually have that formula broken down for you. And this might be something you want to take a picture of the screen or do some sort of screen capture so you can see it. So, this was our basic exponential growth and decay formula that you would have used probably a couple weeks ago. It's been a little while now. So in this formula, your lowercase a that's in front is how much you're starting with. So it could be money, it could be people, it could be any sort of population. And then in parentheses, you would do one plus your rate if you're growing, one minus your rate if you're decaying. So we had talked about things that were increasing in value or populations that were increasing versus things that were depreciating, meaning losing value. Your rate is always written as a decimal, which is usually the most common mistake. So 6%, for example, would be 0.06. And then your exponent outside of the parentheses is how much time has gone by. So that's your basic exponential growth and decay. The difference today is we're going to talk about something called compounding continuously interest. And what that means, it's actually a good thing if you're an investor. What that means is not only are you earning money on your initial investment, but you're also earning interest on your interest. So as I have money in the bank and over a period of time, maybe I earn $100 interest, I'm also going to earn interest on the interest I've earned. So it's like constantly updating. And if you're investing, it's a good thing because the more money you earn, you start to earn money on that money. So the phrasing that you'll see when you know you want to use this type of formula instead of a basic growth is this phrasing, continuously compounded, meaning constantly that constant increase. The formula, a lot of people call it the A-PERT formula because that's what it looks like it says. A equals P E to the power of R times T. A is going to be your final answer, the amount that you're going to have after a certain number of years. Your interest rate is still your R and it has to be written as a decimal. Your T is still time, and your P is it's called principal, which is the amount you invest. It is still that initial amount. So if we go back to my kind of handwritten notes to compare, this was your basic formula. When you're doing a compounded continuously formula, it's going to look like this. Again, this might be something you want to take a picture of, jot down, because this is going to be the main formula that you're going to be focused on today. Again, P is your initial amount, principal. The only reason they use P is because it's often a money formula, and principal is what you call your initial investment. R again is going to be written as a decimal, so instead of 8%, you'd write 0.08. And then T is again is how much time has gone by. So with these two formulas, if I'm investing money in a bank and someone gives me the opportunity of choosing whether I want to do a regular growth or a compounded continuously growth, as the investor, I'm going to compound continuously because I'm going to get more money. On the flip side, if I'm borrowing money and I'm taking out a loan from a bank and I have interest that I have to pay on that loan, I don't want my interest to be compounded continuously because then I'm owing interest on the interest that happens. So it kind of depends on if you're the investor versus the borrower. So the way the problems work is you're going to be given this initial information. So, how much are you investing? In this case, $1,000. What is your interest rate? Again, you want to write it as a decimal, so 0.08. And then we want to know how much you'll have after a certain amount of time. So, after a year, you'd put one in for T. After 5 years, you'd put a five in. After 10 years. So, on your calculator, I want to show you a couple basic things and a couple shortcuts. So, on your calculator, if I just want to put in the basic formula, I'm going to type in 1,000. The E button, again, you have to hit second, and then the button that has the LN on it, it has the E in the upper corner. And then your exponent is going to be your interest rate times your time. So if I want to do times 1 year, I'd do 0.05 times 1 year. After a year, my money would be up to $1,051.27. If you want to be real quick and just kind of shortcut it, you can actually go to second and then enter. That'll put what you just did on the screen, and then you can change your years. So if I want to know what happens 5 years down the road, you can enter it that way. Obviously, a lot more money because it's been sitting there longer. And you can do the same thing, second enter, which will go back and put that formula back up, and you can change it to 10 years. So that's one way to very quickly get a number of answers for different years. We could also Um, oh, I had the wrong interest rate. I apologize. Those should have been 8%. So I did 5%. Let me go back and change that so you actually see the same numbers. So second enter. This is the nice way to fix your mistakes. So I don't know why I did 5%. It was just in my head. So if I want to do 8%, there's your 8%. And you could go back and do that for any with NEM with different values. Another way to do it, if you want to see a whole bunch of answers very quickly, is you could use the table feature of your graph. So to do this, and you don't have to do this, I'm just kind of showing you a shortcut. If you go to your y equals button, which should be blank, so make sure your plots are off, make sure there's nothing there, you're going to type in your initial amount, so 1,000. You're going to do your E button, so second and ln. For your exponent, you're going to put your interest rate. I'm going to get it right this time. It's 8%, 0.08. And then instead of putting a time and at like a 1, a 2, a 5, you're just going to put an X because that's going to change. We're going to have different values depending on how many years we put the money in the bank. Once you do that, now we can look at a table of values and see very quickly 1 year, 2 year, 3 years down the road what's happening. So your table is under second and graph. You have to type the equation in first. And what you'll see here is X is your number of years, and then Y is how much money. Now, the only drawback to this is because we are in the thousands, you won't see all of the digits. I'm going to do a lot of my work asking you to round to the nearest dollar. So just make it easier for you to enter things in when you're doing my assignment. So that is perfectly fine to do this. You'll be able to get to the nearest dollar. So if you scroll, you can actually see what happens 1 year, 2 year, 3 years, and you could keep going and see all these different values for the same situation, the same initial amount, and the same interest rate. So those are different ways to see that. It's also nice to have this table because it helps you make predictions. So then if you look at the second one, and this is kind of where you'll see that idea of making a prediction. So this time, if we're doing $3,500, our account is earning 6.5% interest. And again, you see this phrasing compound continuously. That tells you that you're using this APERT formula. Your initial amount, 3,500. E, your exponent, you're going to write that as a decimal, 0.065. Wants to know how much you're going to have after 5 years. So we're going to go to our calculator. You can get out of this, just do second mode. That'll quit, get to a blank screen. So we have $3,500. E is second and ln. Your interest rate, make sure you type it in right, 0.065. If you just do 0.65, it'd be like 65%, not 6.5%. If you get a number that's really off, like huge, and you're trying to figure out why, it's probably because you wrote your decimal wrong. And then we want to know what happens after 5 years. So we're going to hit times 5. So after 5 years, we're at $4,844. Again, you can round to the nearest dollar if you'd like. And then it wanted to know how long is it going to take for my money to triple? So if I'm putting in $3,500 in the bank and I have this interest rate, I'm compounding continuously, how long is going to have to sit there to get twice as much money? Here's where the y equals is great. If you go to y equals and get rid of that equation and type in our new one, so 3,500, second, and then your ln to get your e, your interest rate 0.065. And then again, instead of putting an actual time, we want to put an X there for time because the time's going to change. We want to see what happens over the course of time. So once you have it entered in right, double check it. You're going to go to your table again. So second and graph gets you to your table. And you can see again, if you scroll up, you can see you started with 3,500. The negative numbers don't make sense here, so we're not going to worry about those. We're going to go forward. And you can see over the course of time how much money you have. So to figure out how long it takes to double, doubling, if you started with 3,500, doubling would be how long does it take to get to $7,000. You're going to keep scrolling. I know my answer's on the screen, but I want to show you what you're going to see on your calculator. And what you'll see is at 9 years, we're at 6,282. 10 years, we're at 6,704. Once we get to 11 years, we have gone past that 7,000 mark. So even though I can't get exact with this, I know for sure that sometime between having my money in for 10 years and 11 years, I'm going to double my money. So your table is a great way to make predictions based on the given information. Last thing, I just want to compare the two techniques because I am going to ask you some questions about the old technique as well. So prior to this, before we did this idea of compounding continuously, we did just regular basic exponential growth and decay. So again, here's the difference. First of all, wording wise, you won't see that compound continuously. So you're not going to use that special formula, the APERT formula. This is going to be a situation where all it talks is about is it's increasing by a percent or decreasing by a percent. So this was our old formula. We start out with a population of 15,000. So that goes in front of the parentheses. We're increasing. So we're going to add 1 plus, write it as a decimal, 0.043. And then our time, again, is just how many years have gone by. So it's 7. You can't have a part of a person, so you'll notice I didn't put any sort of decimal here because that wouldn't make sense. So those are our two formulas. So I guess the biggest takeaway is you should be comfortable using these two different formulas and knowing when to use each one. Basic one here, you never use the E button. This one has your initial amount, 1 plus your rate or 1 minus your rate, depending on if you're going decaying. And then again, time is your exponent. And then this special situation, compound continuously, what looks like this. P is your initial amount. We call it principal when it's money. R is your interest rate. That again is going to be written as a decimal. And then T is time. And both of these things are part of the exponent of E. So that's your applications. What you're going to do now is you're going to go to the Google form and go through the questions that I'm asking. Make sure you have a calculator close by or have a calculator up on your screen because obviously these formulas can't be done in your head. And so that way you can get your answers very quickly. Hope that makes sense. If you email me, please reach out to make sure you're comfortable. But those are your different techniques.